Okay, so in this challenge, we need to take a video and make an ASCIInema version of it. So we can use any technique we want to. I'm going to use image processing. So my strategy is to read the video frame by frame, convert it to black and white, do edge detection on it so I get nice crisp lines, and then I'm going to take a bitmap font of all the ASCII characters, so lots of symbols, and try to compare them bit by bit across the bitmap. Let me show you. We're going to have a set of frames, and I'm also going to have this bitmap font, and it's divided into cells. And each cell has an ASCII character in it. So this is 0 to 255. So inside of here, we would have A, B, etc. You're going to have this, asterisk. You're going to have bar and underscore and plus and all these things. And then what we want to do is we want to, for each one of the same sort of size of the cell, we want to sweep across in a sliding window, comparing against each cell. So when we get to, like, for instance, here, we would hope that this symbol is the best match for that little part of the grid. So then we just fill this up with the closest match. Okay, so I've got Visual Studio Code open here in a browser because I'm going to be doing lots of searching. I've got a blank Python file, and the very first thing we want to do is load that video and display it. Let's see if we can get that working. Capture from playing for the file. We don't want this. Let's go. Okay, well, that's fast, but that's okay. It'll get slower. We got it to black and white. Let's do edge detection. How do we change the size of the window? So in order to make the window relative to the size of the actual video, as opposed to just something arbitrary, I need to get the dimensions of that video. Okay, let's just check to see that it's giving us what we want. Okay, 720 by 1280. Can do a named window, normal, and then we can resize it. Okay, good. So we're able to load the video, we can get metadata for it, we can preview it, we can do some image processing, we're doing the edge detection. What we need to do is now write the video out, the converted video. But we don't want to hard code the 4cc thing, we want to get that from the original video. This is using get3 and get4. I don't really know what those are, but they're probably constants up here. Hey, no, we don't have, that's not right. Why is that not right? We want to show it, but we also need to write it out. So now we're writing files. Let's figure out this bitmap thing now. Wikipedia is always a good place to start. Those are the characters. Yeah, okay, it's a bitmap. That's what we want. We need some sort of tile pixel editor thing. Pixel art. Got the constants in here now. So let's read this in. So we have all the dimensions established for the bitmap font, all the tiles and so on. But what we need to do is generate a sequence that's indexed by ASCII character. So, if I want A is 65. So the 65th entry ought to be that bitmap. And this way I can just go through them linearly and test each one. So to generate this, I'm going to need a three-dimensional array, and I need to slide across. Oh, so this is the second use of this. So I need sliding window across the bitmap font. I need a sliding window across each frame so that I can compare the two. So sliding window is important. Let's create a new function. Let's do it up here. We'll send back the X, the Y, and then the actual data is these range things. So we're saying from Y to Y plus whatever the window size is in height, and then from X to X plus whatever the size is in X. So that should be the rectangle. Now we need our array. We'll call this the font tile sequence. And now we need to slide the window across it. So we got 4X, Y. Okay, that looks like an A. It does look like an A, but why are the values 168? Okay, they're grayscale. There we go. Back to our main logic here. So we've got the bitmap loaded, got the index. Now I need to do a sliding window across the frame, pull out a tile, and then compare it. So we have a blank frame, and we want to slide a window across the incoming frame of font tile size. So for as we walk across, we want to compare it. So let's do another sliding window for X, Y. We have the tile coming in from the window, and now we want to compare to each one of the indexed bitmap. So our strategy is we want to compare the tile from the frame to the bitmap tiles one by one to find the one that's closest. How are we going to determine what is closest? I'm going to difference the two, because we have 0 and 255, 0 and 255, so we can just take the difference, and where they're the same, they'll be 0, and where they're different, I'll have 255 minus 0, that'll give me 255, and I'll have 0 minus 255, but that's negative, and this is unsigned, so it'll flip around, it'll give me a 1. So now I should have a 1 in every place where the two are different. If I sum up the number of 1s, I want the lowest one. Store it in the output. That's the candidate. Let's run it. Wow, it's really slow. But it's working, it's working, it's working. There it is. Okay. Yeah, this is pretty much what I expected, because it's only going to look at the exact matches. So this is the naive solution of that algorithm. It was pretty cool. I think I know how I'm going to fix this, though. Half resolution on the frame, and compare that to a half resolution on the bitmap, and therefore the matches will be more likely to hit. There's probably more clever ways of doing that, but I'm not going to put that much time into this. But let's look at what the final rendered version is. Okay. I mean, you can clearly see the ASCII symbols. You got the plus minus, you got a bunch of these minuses and underbars, greater than, equal, question marks. Okay, that's not bad. All right, so I'm pretty happy with it. I mean, it meets the basic requirement. You can kind of make it out. A little bit more work. I think we'll probably have something nice.